Good afternoon, dear students. Is my screen visible and am I audible? Somebody please respond.
Yes, sir.
Yeah, thank you, Manishankar. So, welcome to another class on data structures and algorithms, module 2. So, in this class, we'll be majorly focusing on multi-dimensional arrays and how these multi-dimensional arrays are represented in memory. Before that, what we have discussed yesterday we discussed about sorting. What is sorting? And sorting, it is the task of arranging elements into an array in a particular order. And how many passes does bubble sort technique require to sort array of n elements? So if there are 5 elements, so it has to go for 4 passes. If there are 10, it is 9 pass, and 9 iterations. If there are n elements, so n minus 1 passes are required to sort the array. So that is one thing that you should always note from the yesterday's class. And uh, another concept yesterday we discussed, what is searching? Searching is the process of determining whether a specific element is present in the array or not. And of course, yesterday I think some of the students were asking, sir, what is about multiple elements present in the array? Remember, a simple search, linear search, will always look for only one concept, whether that element is present in the array or not. It doesn't matter whether it is having multiple existence or not. So that is a different issue. But searching is all about whether the specific element is present in the array or not. So that is what you should try to understand. And next, at a maximum, how many elements would the search technique require to traverse in an n elements of the array? Of course. So, the worst case here we are talking about, he is asking for a worst case. What is the worst case of searching? So, the best case is the first elements itself, it is your array element, searching element. So, then it is best case. The worst case is the last element. You are looking for an element, the element is present at the last. So that is the last element. That means it has to compare all n elements. So that is what it is all about. So the maximum time that it will take for searching is n. So if there are n elements, so n times comparison it has to do. So that is what yesterday we had discussed. And coming on to today's class, we have already seen multi-dimensional arrays as array of arrays in the previous chapter, that is previous module. Unlike one-dimensional array, which have only one subscript, a multi-dimensional array has multiple subscripts. That is a major difference. And if you look at an example, for example, a two-dimensional array uh, has two subscripts, one for uh, the row representation, another for the column representation. Similarly, one of the most widely used instance of multidimensional array, that is two subscripts, There is matrix representation, and it is used to programmatically realize matrix with its first subscript to represent the row, and second subscript to represent the column of the matrix. So that is one very important thing. And how do you represent a matrix in memory? So the title of this particular topic is representation of multidimensional array in memory. So that is what we have to understand, how exactly memory is allocated to two-dimensional array. That is, the representation of two-dimensional array in memory is not like a grid structure. It is not like a grid. It is not like how you are imagining. It's not a grid like structure of the matrix. Instead, it is same as the one-dimensional array itself, which represent the sequential elements in the memory representation. Either it stores array elements row by row or column by column. So it is the same. It is the same. So some of the compilers use column major representation. Some use row major representation. Row major representation is nothing but row by row data storage, column by column data storage, allocating array elements column by column. So let us look into the diagram figure 4.4. How exactly? Suppose you have imagined a matrix 3 cross 3 which has 3 rows and 3 columns. Observe here very carefully. The first row, this is a row major. This is a row major order. That means some compilers are there, C compilers, they store rows first, row by row. The first row, this is first row. The first row is stored. Next row is stored. Next row. Next third row is stored. You can see third row. First row, second row, third row. So row wise it is stored. Same way in the memory sequentially, if it is represented in the memory as an array, so first row, next second row, and third row are stored. Of course, this is row major representation. This is a row major representation. So that is what we have to understand. Further, the next type is column major representation. So in column major representation, what happens? Column wise data are stored. First column is stored first, like this. You can see row 0, column 0, row 1, column 0, row 2, column 0. So this is first column, and of course you can also have the second column. So you can have this first column. Next, this is first column. The previous one was the zero column, and the next one was next one would be the third column. So certainly you can represent it. You can represent it the third column. So third column is nothing but your row 2. So it is, you can see it is a representation. So first column is represented here. Next column 2 is represented. Column 3 are represented. So this is the memory representation. This is the memory representation of the two-dimensional array, irrespective of the uh, grid that you imagine, the size of the matrix you imagine, size of the two-dimensional array you have. So everything is stored as arrays, that is sequential elements. And of course, how exactly this major row major and column major memory addresses are calculated. So when we look into the previous picture, figure 4.4, the elements of two dimensional array are stored at consecutive memory locations. The only difference in the order in which the elements are stored in memory, and of course the column major and the elements are stored column by column, while in the row major, so it is stored row by uh, row, but both these memory representations are inbuilt in the programming language itself, and the programmer does not have a choice of selecting a particular representation of storing the array elements. And of course, uh, you understand how exactly, even though it is stored sequentially, whenever you write a of 3 cross 3, that means third element in the third row, so that is so it has to go through 0 1 2 3, third row, 0 1 2 3, third column. So it has to go to that particular element only, and it has to fetch it. So how does it do? It employs a formula, that is address representation of formula for this major implementation. So observe this formula very carefully. Whereas B is the base address. Suppose if you want to represent A of ij, some element, I want to know the address of a particular element A of ij. For this, I have to write B plus W into N into I minus LBR plus J minus LBC. So you have to understand this concept. Suppose I want to find an address of a particular element in the array. First, you should know the base address. Base address is nothing but the starting address, starting element of the matrix or multidimensional array. The first element address, you call it as the base address. Base address. W is a word size. Suppose word size is nothing but size of the data item. So for integer it is 2 bytes, for a character it is 1 byte, and for a float it is 4 byte, and for double it is 8 byte, just like that. So the word size depends upon the what data type you use. So, and n is the number of columns, because we are working on row major elements. So since we are working on row major elements, so n represents this n. So this n represents, so the column number of the column number, how many columns are there. So columns, how many column, number of columns, and ij are indices of that particular element, and LBR, lower bound of the row index. Lower bound. What is the starting row number you are starting? Some people, they start, some programming language they start with row number 1. In C language, in Java language, you start with row 0, 0 comma 0. You start. But in some programming language, they start with 1. So lower bound index is 0 by default, if they have not given for C language and other Java languages. Same way, LBC is the lower bound for column index. Lower bound for column index is by default 0. In case in the question, if they have given any other lower bound, so then you have to consider that. Okay. So here is one exercise example. In the examination, they ask a question like this. Probably, if you have paper pen, please note down. If a matrix 10 cross 12 matrix is implemented using array A of 10, 12. If the base address of the array is 200, so they have very clearly mentioned the address is 200, and the word size, that is each element will occupy 2 bytes. Then address compute the address of the element a of 4 comma 7. So you have to find 4 comma 7. First you have to employ row major. So the previously we have discussed only row major. So now we work on only row major. The formula is very clear. Row major address of A of ij, there is address of 4 comma 7 is equal to b plus w into n I minus lbr plus j minus lcr. So uh, you have to understand uh, b we know it is already given, it's 200 is the base address, and w is nothing but the word size. You can see word size. So word size also they have mentioned, it is 2, and number of n is nothing but number of number of columns. How many columns are there? 12 columns are there. So n is nothing but it is 12. N is 12, and for both they have given, assume that lower bound of both row and column indices is 1. So lbr is also 1, and lbc is also 1. lbc is also 1. So put that value 200 plus 2 into 12, 4 minus 1, because what is this for I value? I value is nothing but he has given already. I is 4 and j is 7. I is 4, you just put the value of I, and j value you just put it here. So finally you calculate 200 into 2 into 12, 12 into 3, that is 36, plus 6, 7 minus 1. So it is 6. So 36 plus 6 is 42. 2 into 42 is 248. So this is the memory address. If the array is starting from 200, so A of 4 comma 7 is available in 240, 284, 284. So this is how it is calculated. And observe, now we have checked only for row major. We have observed only for row major. We have to calculate it for the column major also. Yes. What is exactly column major formula is all about? Very simple. There is no change in the formula. Same, b plus w into m, where m is the here, sorry, m is the number of rows. I should write it is number of rows. So it is number of rows. So it is m, it is not n. It is m is number of rows. So m should be number of rows, and j is the value, and you should take lbc, j minus lbc, and I minus lbr. So lower bound index of the row, lower bound index for a column index for the column. So that is the there. So in our previous example that we have calculated, we have already calculated for row major what is the thing. Now we have to calculate it for the column major. We know already b is nothing but 200, w is nothing but it is 2, and the number of columns, so sorry, number of rows, number of rows, that is m is equal to 10. So 10 you have to write, and j value we already know, this is ij, j is 7, You write 7 directly. And LBC, we know it is the lower bound of both row and column indices are 1. You represent 1 here and 1 here also. So apply this formula: 200 plus 2 into m, that is for column major you will take a number of rows, for row major you take number of columns. So that is the only difference. So m is 10 into 7 minus 1. 7 is already, that is the j value, 7 minus 1. 1, why we are taking it is LBC. And same way 4 you take, and LBC. So since LBC is there, the LBR is there, it is 1, you check. So 7 minus 1, 6. 6 into 10, 60. 60 plus 4 minus 1, 3. 63. Into 2. Into 2. 63 into 2. So 200 plus 63 into 2, that is 126. So 200 plus 126 is 326. So this is how you should calculate the memory address of A of 4 comma 7 in the case of column major order memory representation. In the case of column major representation of the memory address. And of course, these two are very very important. These two are very very important. Now, before we move further, what is row major and what is column major? Row major is the memory representation of a two-dimensional array in row by row fashion, and in column major order it is the memory representation of a two-dimensional array in column by column fashion. So this is the these are the two things that you should never forget. These are the two things that you should never forget when you are representing matrices, are uh, the what you call it as two-dimensional arrays. Now let us look into the realization of matrix using two-dimensional arrays. Of course, two-dimensional arrays are most commonly used to realize matrices that you already know. And of course, the first subscript signifies the row of the matrix, while the second subscript signifies the column. So the operation on the array representation of matrix can be performed through a single programming language, a simple programming language, that is in C. And C always makes use of the row representation of matrix values. And of course that's why you see 0 comma 1, 0 comma 2, 0 comma 3, and 1 comma 0, 1 comma 1, 1 comma 2, 1 comma 3. So 2 comma 0, 2 comma 1, 2 comma 2, 2 comma 3. So it is representation of matrix happens like this, the row major. And of course, let us write one simple program. Uh, the program we have to write to realize a 3 cross 3 matrix. In this matrix, what we have to do, the size it is already given 3 cross 3. So matrix you have to. So you have to first read the elements, first initialize the matrix 3 cross 3. Then I and j are two elements that are required for looping. You create two loops for I 0, I less than 3, I plus plus. Same way, j is 0, j less than 3, j plus plus. You print the element ij value so that whatever the element that you are typing in, user will have to understand, and he will enter the value. That is, he will do the scan for. So he reads the matrix. So here you are taking the input, and later what you are doing, you are displaying for I is equal to 0, I less than 3, and every time you print a new line and a tab space, so that the matrix will be appearing at the center. So later you display the matrix inside a for j loop, inner loop. So again, j loop starts with 0 and goes up to 3. So print percentage d m of ij. So you are trying to display. So this indentation will certainly displace the two-dimensional array at the center. Okay. Anyhow, we'll see this uh, execution. I'll take you to execution. The same. I'll send the same link in the chat box so that you can also execute it. You can see. Yeah. Just type the same thing. I just copy it. So I put it in your chat box so that everybody can simultaneously execute along with me. So you can see that. All right. Now, observe. So the same program. I'm scanning, I'm reading, and what it is doing. So all the elements what I'm reading, I'm just already typed in as I'm running through cloud enabled. So as soon as I run this code, so 23, 45, 78, they are stored as a row element. You can see 22, 45, 78 are stored as a row, and 43, 28, 90, 43, 28, 90 are next set of row elements, and 83, 62, 15 are next row elements. And of course, so my intention is to show in this program, as soon as I read the values into the array, so array stores them row by row, and of course when I display them, it is displaying as a row. The same thing I can visualize. So same thing I can visualize. Uh, of course, you can see using C visualization tool. So we can certainly visualize. The program is the same. So here, instead of reading, I just store them like row elements directly. So this is clear indication. As soon as I run this, I am storing this, and as soon as I run this, you observe here it is storing like 23, 45, and 78 row major elements. 43, 28, and 90, and so same. As soon as I display them, it is displaying the same thing. It is displaying. Now I do a small change. I don't specify it's an array of array. I just write it as a single dimensional array. Let us see how it is going to behave. So I don't write it exclusively. I just write it sequentially. 3 cross 3 means 9 elements. So 9 elements, I straight away I'll write it, and you just see how it is going to behave. So you can just see here, and yeah. So I've just written 9 elements. You can see 3 plus 3, 6, 6 plus 3, 9 elements. 9 elements straight away have put. Now I just want to represent in the memory, and I want to print it. Let us see how exactly it will do. So you visualize it. You can certainly see how they are done. So yes, as soon as I run this code, so what happens? Yes, even though I have not made as row by row, automatically it is taking it as row column, a row major representation. So the GCC what we use in Unix based C compiler, it majorly uses this kind because it is visualizing. For visualization tool, they have used, and it is a row major representation. Yes, you can see. So they are represented, and I am trying to display them. So you can certainly see there. So it is displayed. The same link I generate and I put it in the chat box. You can also try it simultaneously with me. You can also try it simultaneously with me. So that is pretty simple. So today we understood how matrix are represented, especially the two-dimensional matrix are represented row-wise and column-wise, and how to calculate the memory address of particular array element with the indexes I and j. How to calculate? So that is what majorly is all about. And finally, we discussed about representing a matrix, and how your compiler, whether it will use a row major or column major, we understood. So that's about. And the program analysis for the previous one. So we use ij and m are the variables that are used to declare matrices, and ij for looping. For I loop is row by row iteration, and j loop is for column iteration. And many times we use scanf to scan the matrix elements, that is m of ij. So that is, and for printing without ampersand, just write m of ij, so that we're going to print it. So this is about the program. That's all for today's class. In the next class, we'll be discussing about matrix operations, that is addition, subtraction, multiplication, and transpose of matrix. So these are the four operations that we do it in next class using multidimensional array, that is matrix. So that's all for now. Thank you for your patient listening and active participation. All the class resources are available in this particular website. Have a wonderful day.